Hi everyone, for this question it said water is being heat in a kettle. At the time t seconds temperature of the water is theta Celsius. The rate of increase of the temperature of the water at any time t is modeled by the differential equation we are given. d theta dt equals to lambda 120 minus theta, where theta is less than 100 and lambda is a positive constant. So in our story timeline here, you can see our rate of change is d theta and dt. So means our variable here is T and the quantity of temperature in theta Celsius. So start from the question A. Given that theta is 20 when t equals to 0, theta 20, solve this differential equation to show that theta equals to 120 minus 100 exponential negative lambda t. So to solve this, we can use separable method where theta we rearrange to the left hand side, dt to the right hand side. Then we integrate both sides. So when integrate fraction, it will be ln in the modulus of 120 minus theta. Don't forget, divide with your coefficient theta here, which is negative 1. And then this one integrate with respect to t, it will be lambda t plus c. Then we're going to simplify this. So negative lambda t minus c. So minus c can be maintained as positive c, as constant negative, and constant positive is still is defined as constant. So like c is 3 is a constant. When you 3 is negative 3 also defined as a constant. So we just remain it plus with a constant. Then we unlock for this log. It will be e negative lambda t plus c. Then we simplify the power for the exponential. When power plus, it is equals to multiply ec. Therefore, theta can be equals to a e negative lambda t, where ec is a constant. We denoted it as a new constant. A theta will be 120 minus a e exponential power negative lambda t. And then the question give her is when t, so substitute t equals to 0, and then theta is equals to 20. E to the power of 0 is 1. So a here will be equals to 100. Therefore, this solution theta is equals to 120 minus a 100 e negative lambda t. Then when we move to question B, he said when the temperature of the water reach 100 Celsius, the kettle switch off, given that lambda is equal to 0.01, find the time to the new nearest second when the kettle switch off. So for the second part of the question, it means that substitute lambda equals to 0.01, theta equals to 100 to find out what is your t. So substitute into the solution that we have find just now. So we move back 120, negative 20, then negative negative we get exponential 1t, 20 over 100 which is 1 over 5. Then simplify the exponential base will be log to the right hand side 1 over 5. So log e will give us ln. Then the t here will be ln 1 over 5 over negative 0.01. So the answer will be 160.9. And then it asks us to correct to the new nearest second. So the t value here you have to round off to the second, nearest second will be 161. Then we see what is important here for the first part. For the first part, we must able to separate the differential equation and then differentiate left hand side using formula fraction, which is divided by -1 of the coefficient data. It is important. Then integrate for the right hand side respect to t we have lambda data plus c, and then we simplify. So move the unlog here, simplify this log and exponential, and then come to the stage of data as a subject. Then substitute the initial value so that to find out a. After that, substitute back to the equation to show the equation obtained. So for question B, so what is important here, the 3 marks. The first one is substitute our information and then simplify to find out the t. Lastly, round off the time to the nearest second.